Let's talk about rational exponents. Radical expressions can be rewritten using rational exponents that will allow us to take advantage of exponent rules to help us simplify problems. For instance, the square root of x can be rewritten as x to the 1/2 power. It is helpful for us to think about the understood parts of this expression to see where that exponent comes from. Square root of x has an index of 2. This x has an understood exponent of 1. The exponent becomes the numerator of our fraction. The index becomes the denominator of our fraction. So anytime that we want to convert from a radical into a rational exponent, whatever is the index will go as the denominator of the fraction. Whatever is the understood exponent will go as the numerator of the fraction. Let's look at the one here, the fourth root of x squared. Our index becomes the denominator of the fraction. Our exponent becomes the numerator, giving us x to the 2/4 power. This is a good example of one that having it as a rational exponent allows us to do more simplifying. 2/4 simplifies to be 1/2. So x to the 1/2 was the same as the fourth root of x squared. Generally, when you've started with a radical, you want to finish with a radical. So we would usually take one more step and change x to the 1/2 into the square root of x. The denominator is the index and the numerator is the exponent, both understood here. Well, we want to be able to go both directions with these, so let's change the expression into radical form next from a rational exponent. Let's take x to the 5/6 and make it into a radical. The denominator becomes the index, the numerator becomes the exponent, so x to the 5/6 power is the same as the 6th root of x to the 5th. All of the rules for exponents still apply, even though now we have rational or fractional exponents. For instance, the product rule tells us to add exponents when we are multiplying things together that have the same base. To do that with rational exponents, we're going to need to have a common denominator. So if we were multiplying x to the 3/4 times x to the 5/8, we would first need to get a common denominator, which for this problem would be 8. Let's change 3/4 into 6/8. And now, since we've got the same denominator, we'll keep the base, add the exponents together. 6/8 and 5/8 together made 11/8. So x to the 11/8 is our product. The quotient rule says that when we are dividing two things, we subtract the exponents. We'll again need a common denominator to do that. X to the 5/8, x to the 1/4. The common denominator is 8. Let's change 1/4 into 8ths, which would be 2/8. Now, since they've got the same denominator, we can keep the base and subtract exponents. 5/8 minus 2/8 gives me 3/8. And then the last rule that really matters to us for rational exponents will be the power rule. That's when we raise an exponent to an exponent. When that happens, we're supposed to multiply the exponents. So if we had x to the 1/2 raised to the 4/3 power, notice that the 2 denominator here and the 4 numerator there can be canceled out if we're doing multiplication. Any top and any bottom can cancel with multiplication. So if you cancel the 2 here and the 4 there, you would be left with 2 on the top. 2 times 1 gives me 2, and there's a 1 understood on the bottom, times 3 gives me 3. So 2/3 would be our exponent. We multiply exponents when raising a power to a power, and we can cancel out any top and any bottom. Rational exponents are a fancy way of writing a radical. The index becomes the denominator of a rational exponent, and the exponent becomes the numerator of a rational exponent. All rules for exponents still apply.